Let's get through the agendas for today's meeting. So, if you the agenda for today's class is we will understand what is Elasticsearch and how Elasticsearch is different from the traditional database which we used to have like MySQL or MS SQL and the various terminologies involved in it, like the shard, documents, index, primary shard, replica, node, cluster. We will understand what these terminologies are, and we'll also understand the architecture of the system and the installation part. So have you installed before? Have you installed this in your machine before? Search.
No, no, no.
Okay, great. So if you face any difficulty in understanding any of the point, or if you face some difficulty, you please you are free to stop me, okay? So that I
Sure,
can
sure.
discuss in detail about that. Okay. So if you read the first point, you might be seeing that there's a jargon calling something called real-time distributed search and analytics engine. The point might look very simple, but it contains like lot of hidden information inside it. If you just understand what is a real time here, so real time is meant by like there are kind of two kind of systems are there in the market, computer systems. One is the real time and near real time and the batch processing system. Have you heard about these terminologies before, Matthew?
Yeah.
Okay.
I heard about real time and batch processing. Nearly real time. That concept I'm not that much familiar.
Sorry, please come again. Batch?
Yeah, yeah. I heard about this real time and batch processing systems, but this NRT concept that is not much familiar for me.
Okay. NRT is kind of very similar to real time, except the difference is it has like a few seconds delay. Like if you are
Okay.
watching a live telecast match on a TV, it is not
Mm-hmm.
real time, right? It is providing just the near real time. At least there will be like few seconds of delay in the live telecast, right? Do you agree with me?
Okay. Okay. Yeah. Got it.
Yeah, there's no big difference on the near real time system. So the reason I mentioned here the point here is a real time is like in Elasticsearch, the system or the data, whatever you index into Elasticsearch, can be visible to the user in three modes. One is the real time, near real time, and the batch mode. Batch mode is not so prevailing here, but the reason why I just pulled here is if you check for the competitor product of Elasticsearch, you might have heard something called Solar. But nowadays, if you see on the market, all the companies are going towards the Elasticsearch, not for Solar. So the main difference between Solar and Elasticsearch lies in this factor. So Solar is a system which works in the batch processing, but in case of the Elasticsearch, it works on the real-time mode. So there is a difference here. So
Okay.
like there's a parameter in Elasticsearch in which you can configure whether the search results can be real time or near real time. It is completely configurable. It's a user control behavior. Okay.
Okay.
And then you see something called distributed search. And this is like a most important, most pressing concept here. Let's say, let me start with an example here. Let's say you are in a classroom with a faculty. Suddenly faculty comes in and start giving the mark sheet, and she wants to someone to total the mark sheet or the transcript which she has. So in generally, the faculty or teacher gives the mark sheet to the student. Let's say she gives to the one student. Let's say they have 50 transcripts. Even let's assume that the student can compute the total in less than 1 second, maybe 1 second. So it will take like 50 seconds to compute the result. Do you agree with me?
Yes.
What if the same faculty tries to give the mark sheet into 5 people? Maybe she decides to give the mark sheet to 5 different people, then my time or the throughput time is actually reduced to 10 seconds, right? Do you agree?
Right. Right.
So this is the key fundamental concept here. So if I have my large amount of data to be processed, if I divide within like multiple machines or a node, so I can improve my throughput time. So that is the key essence part here. Okay. So
Okay.
if you increase the number of people to work for a given job, definitely there will be increase in the throughput, and that is the idea here.
Okay.
So similarly in computer also, let's say if you have 10 GB of data to process or do after search, then your searching time might be difficult if you having a only one machine, because it all depends on the hardware and the software, right? So let's say
Right.
if you have like a 10 machines which you can process or helps you to compute, then you can get the speed in a much faster rate. So that is the main concept or the idea overall here. So you mentioned that you have a database administrator, right? What is the database you
Right.
have worked before?
MySQL and MariaDB.
Cool. In MySQL, have you did partitions?
Partitions I have not actually did, but I know the concept.
Okay. So if you have done the partitions or if you heard about partitions before, you might have seen that they do partition for like a very large table. So they divide
Right.
into like small pieces to improve the throughput. Because if they have like a 10 million or 100 million records in a table, the table speed, travel speed is actually heavily affected. So they divide the pieces into multiple chunks based on some hashing number, like hashing based on the ID or some different condition. Based on that, your document will be split equally across the machine, now across the machine in the same machine into different pieces. So that is like one level of part improving the speed of a system, and which is something called the same node partition. So the partition what we are speaking in the distributed search here is the same partition pieces will be divided into into different computers.
Okay.
You are understanding what I'm saying, right?
Right. Right.
So that is the factor here. And then there's something called the replica. Let's say the same example, if I divide into five pieces, like for the same classroom, I can get in 10 seconds. What if I have a replica again? So again, this work as a duplicate replica while you're reading it out, then my performance further increases, right? Even though some
Right.
student didn't turn up, the other people would have who been assigned the work can take up the work and complete it, right? So that's where the distributor concept actually comes here. You got it, the overall big picture, right? How distributor search really works.
Yes.
Great. Then you have a word called something called analytics engine. So what comes to your mind? Something someone says analytics engine here.
Analytics engine, probably they do some evaluation on the data which you are processing, decision
Okay.
taking kind of.
Okay, understood. So if you have had experience in dashboard and the other stuff, you might have seen that people would retrieve and see like last 15 minutes what's happening in the system. So in general, there are like four kind of analytics there in the market: descriptive analytics, diagnostic, predictive, and prescriptive. So these are the four verticals of the any analytic systems available in the market. So general dashboard analytics, if you encounter, you might have seen something called descriptive. So whatever happened in my system, you are able to see in a dashboard view. That's the analytic part. So with Elasticsearch, you can do like analytics what you can do in MySQL or MariaDB. Like you might have used something called min, max, count, and those kind of mathematical operations, right? So if you want to do
Right.
like how many people have did this operation, the analytics view, everything can be done in Elasticsearch also. That is
Oh,
the fundamental idea over here. Then
okay.
there's a point something called Apache Lucene. Have you heard about Apache Lucene before?
No.
Okay, Apache Lucene is a library on which Elasticsearch is built top of that. So I said
Okay.
as a library, but Elasticsearch Stack is a like complete framework. So you know the difference between the framework and a library? Any chance?
Um, I know about the library. Library means a group of predefined functions and all.
Yes, you are right. Yeah,
I'm not
great.
wrong. Then about the framework, you may have to explain maybe.
Okay. So, can you think of some example for frameworks available in the market?
Uh, I think this Python is having some framework which is called or I don't remember the names, but
Okay. So, have you heard about something called .NET framework?
yes, yes, yes.
You might have heard something called .NET framework, AngularJS as a framework, React as a
Right,
framework, Django. But
right,
the
right.
funny part, the funny part is jQuery is a library they call it. All the logging systems they call as a library. They don't call as a framework. Then there is a solid difference between the library and a framework. Now you come to a point, right? There's something fundamentally different between the library and a framework. Do you agree?
Yes.
Okay. So the main difference between a library and a framework is a library you can use it in the way which you like to have. You understood what I'm trying to say? Library you can
Okay.
use it as flexible as you want, but in case of a framework, you have to follow their own script standard for that. So if you even want to create some standard class or template, you have to follow the standard what is being prescribed in the framework, which you can't do it normally.
Okay.
So that is like a fundamental difference what you see. Jay, give me a minute. I'll just come back and online like another like a minute, okay?
Okay. Okay. Cool.
Hello, hello.
Uh, Hello.
Can you hear
Hello.
me?
Yeah, yeah. Okay.
Great. So, as we discussed a few minutes earlier, the library can use it at your convenience, but in a case of framework, we have to follow their norms. And one more
Okay.
advantage of using framework is frameworks comes with almost all built-in boilerplate stuff. What I mean by boilerplate stuff here is all your security, authentication, and the encryption. It all been satisfied by itself. You will have to worry about the security aspect and most of the stuff. If you take a .NET framework, you almost have everything is as secure as possible. But if you think like if you want like a secure jQuery application, that is not possible. It is up to your responsibility. So the main difference, what I would say, actually, I'm hearing a lot of noise from your side.
Just 1 second. Hello.
Yeah, yes.
Is it fine now? Some construction works are going on outside.
Oh, right. It's 2 minutes still. Why? Yeah, it will start by 9 o'clock, right? Why are you starting by 8 o'clock itself?
Okay, see, the person told me that it's only from 8 to 9.
Oh, interesting.
If you do have sessions after 8 o'clock, I mean, I can go to my office and I can take this call from there.
Okay, I have office. That is a problem. After
Okay, okay.
9, I have to be in the office. That's the problem.
Okay, okay. So normally, what time do you have sessions in morning?
Morning, I start from 6 o'clock. If the candidate just want to join, we start from 6 o'clock. 6 to 9,
Okay,
I'm available. Or else I will
okay,
take on the evening part. Evening in sense like from 9 to 12. So now there's a batch going on for people from 9 to 12 who are staying in UK. So that batch is already going on. That's why yesterday when Mind Magic's call, I said, you please schedule on the morning part. That is the case here.
okay, okay.
So you want to change in timing?
Um, right now I'll just check out for 1 week because maybe from tomorrow onwards I'll reach office little early. Then this sound issues will not be there.
Okay. Yes. Try to see, or else we can come for a better idea or a better understanding of time what we can work.
Okay,
No problem. So next part is like it is, and one more difference what you have to understand on the Apache Lucene as well as with the Elasticsearch is like it's. I'm already said that it's built on top of Apache Lucene. Then how could be more different? How what could be the more pressing factor? So it's already built on top of Apache Lucene. If you search on Apache Lucene on internet, you will be amazed to see that most of the feature what you see of the Elasticsearch is already available on Apache Lucene. Then you might have an encounter a strange question. Then what I'm really doing with Elasticsearch? That question will most of the people will understand. Okay, all these features are there. Then what I'm really trying to do with what is it called? With Elasticsearch, if you carefully observe all the logging part or all the clustering ability is being done in the Elasticsearch, not on the Apache Lucene. Apache Lucene is like a Java-based library, so only the Java-based system can interact with Elasticsearch, Apache Lucene. So if your application is running Python or C Sharp, then you don't have a choice. One second.
yeah.
Hello?
Hello.
Yeah, can you hear me better now?
Yes.
Okay, I switched from mobile to desktop. That's what I should do, but they had a problem in my starting my desktop. Oh, can you see able to see my screen?
Yeah, I can, but I can also see share your screen some pop up.
Yeah, I'll disable that. So what's it now?
No, it's still there.
Still there. Where do you see the pop-up? Is in the top left or
I mean,
where do you see?
it's covering the entire screen.
I think it's for you, I guess. Can you click on cancel for you? I think it's the prompt for
Oh,
you,
it's
I
yeah,
guess.
yeah, 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 yeah. It's mine. It's mine. Sorry.
Yeah. Because I actually made you as a presenter, then I changed to me as a presenter. I think during that time it have, might come for you.
Oh, okay, okay. Yeah, it's gone.
Yeah, great. So we were discussing about the Apache Lucene, right? So all the
Right.
clustering abilities were not part of the Apache Lucene, and pain point in using the Apache Lucene is you just have to use your Java-based application to interact with Apache Lucene. Let's say if you tomorrow come and say that I have like a system which I can Python or a C sharp, I can't directly interact with the Apache Lucene. I have to relay support on Java. I have to interface in somehow to get the job done. But what Elasticsearch people have did is they wrote a wrapper. So that wrapper consists all the capabilities of the Apache Lucene, as well as they added like more functionalities to that. So kind of functionality, what you see like the clustering ability, distributed search, and few analytics operation. Then the another important thing is all the interaction to the Elasticsearch has been done through the help of the REST API. So earlier the system was interacting with the Java, but if you want to interact with this kind of system, everything comes with the REST API. Now the question would like you would like to ask would be H, why REST API? Why not like other interfacing mechanism? So the REST API has like a beautiful concept or the idea on the whole. REST API protocol can be understood by any language which is being popular right now. Starting from C, C++, Java, Python, or Scala, any programming language can understand the REST API so easily, so it can interact with Elasticsearch without any much of problem. So, have you used REST API before, MacCube before that?
Yeah,
Any experience?
yeah, yeah. In current project, we have a system. What we did for the current project is that we build a data warehouse, and on
Mm-hmm.
the top of that, we build a dashboard system for our customers.
Okay.
Now, this interaction between this particular dashboard and the database is happening through the RESTful APIs. I mean, REST APIs are using for that. I mean, to take the data and do all these kind
Okay.
of
Okay.
activities. We are using something called a Dream Factory.
Okay. Okay.
So,
And
yeah, I'm familiar with that. So
okay.
basically, our intention is to we have an application, as I told you before, which is generating n number of log files. Our interaction,
Okay.
our ultimate aim is to read all these log files, which is generating by this application, and
Mm-hmm.
we have to create it with this particular dashboard.
Okay. So understood. Okay. So you might have already heard about REST API. So there are like
Right,
four kind of general HTTP verbs, which is the get command, post, put, delete. You might have heard these commands. If not,
right.
we will see in detail about that in the while we doing the querying part. So the
Okay.
last fourth point, what you see is something called schema free. Being the people you experience in the SQL background, so always we know that if you want to create some table content, first we might have to create a database, and then we will create a table with the properties. What I mean by properties or the schema here is we will say that create table name, and we will open the bracket and say what are the different columns it can contain along with the field name, correct, right? The field data
Right,
type. If it's a name,
right,
so we define the value 255. If it is age, we define a shorthand or int. We try to define the what is the data type of the column. Then once it's done, if you want to index, we also try to enforce the same principle. If there is any deviation in the data type, then you are not allowed to do that, right? So, but
Okay.
in case of Elasticsearch, there is no hard restriction saying that only these data type we have to define the data type before even you start working. It's not like that. It is like kind of very flexible. So before even you want to put some data and start playing around in Elasticsearch, you are not required or you are not obliged to create a mapping before that. So the word what we call in SQL is the schema, but people in the Elasticsearch would call as a mapping. So that's like a
Okay.
small transition from SQL to Elasticsearch. Okay.
Okay.
Then you see something called open source here, right? So the
Yeah.
all the components of Elasticsearch is being open source. If you just go to the GitHub page, you can get the complete control and you can get the overall understanding what is Elasticsearch, and you will get the complete source code. But you can't contribute back. Only the Elasticsearch company can work on the changes and can push the changes to the master. But anytime if you wish, you can locally change some, make some changes to the code, and you can keep it locally if if there's a diard need for you. Then you see
Okay.
something called document-based database. Like the have you heard about CAP theorem before, Matthew?
Not really.
Okay, CAP theorem is like a theorem which helps us to decide what database we like to pick it up. So generally, like now, like three kind of flavors of database came into the market. One is the SQL database, and one is the NoSQL, which you might have heard about. And there's
Right.
one thing, something very recently came up, the database, something called New SQL, something called NUW. New SQL is
Okay.
kind of very stable market, which has the hybrid feeling of both the SQL and the NoSQL. So you can interact with the system through the traditional SQL language, which you know, but it
Hmm.
contains the properties and features of the NoSQL. That's something very cool and fascinating, right? So you are
Right.
without losing the SQL behavior or SQL knowledge, still you are able to use the benefit of NoSQL. People actually went to NoSQL because they need to scale the system when the workload is pretty high, which was not possible with the help of MySQL. MySQL found it very hard scaling after like 400 million or 5 million record. It found really hard even to do a small search on top of that. But if you think like a 400 by 500 million on a distributed mode, that is it's nothing. You can get the result in a few seconds itself. But in case of MySQL, it might take even 30 40 seconds even to do a count operation. So that is the big difference what people say here. And it comes under family of NoSQL, and the NoSQL family also has like a lot of divisions here. If you open and see the NoSQL here, there are like a three kind of a database system would be available for a NoSQL. One is the key value pair. Just click on
Hmm.
here. Key value graph and other stuff. Can you see here?
Yes.
Key value, document based and column based. The column based and all will go for the HBase and Cassandra. Document based will have something called MongoDB and Elasticsearch
Yes.
and these database. Key value pair are the Redis or the Memcache, which you might have heard before, right?
Yes.
So these are
Yes.
the different formats or the different kind of database available for the NoSQL market. If you just see, this is like a column family graph, document, and the key value pair. So
Hmm.
these are the different format here, and our Elasticsearch comes in the format of the NoSQL here.
Okay.
NoSQL in the branch of the document base. That's the key idea here. Where's the document? Yeah. So this comes under this. Oh shit. Yeah. And next is like who are all using the Elasticsearch. Almost like major companies in the world are using using Elasticsearch, but you might have used GitHub and Stack Overflow, right?
Yes. Yes.
Can you think where Elasticsearch is being powered or being used? Can you make a wild guess? I'm not expecting correct answer, but you can make a wild guess. It's fine.
Is it on the search option? I mean, on where we are searching for something on the top.
Yeah, you're right, almost right. Anything else? Pop, that's kind of very perfect. Then anything else?
Mm. Or
Even for
maybe.
Wikipedia, it holds good. Even Wikipedia is using Elasticsearch as a backend engine.
Oh, okay. So basically, Elasticsearch is a document-based database, right?
Yes, you're right.
Okay.
So the people where you might have seen this, but you are not maybe we are not realizing where it is being used. Let's say let's go for Wikipedia. When we go inside that, and if you do like a searching part on the search bar or in the any repository of the GitHub, the first part let us say something called maybe computer. Can you see as I start typing, my solution comes based on my string what I input. Can you see here, right? So this is
Yes.
something called autocomplete feature in which the people call it. This is also available in Google, right? If someone goes to
Mm-hmm.
Google and start typing what is there, we start getting the document related to the word which we start typing, right? So that is
Yes.
like these features also being powered by Elasticsearch. This is something called autocomplete feature. And the another
Oh,
feature, as you said, search is also true. If you go for any GitHub document and if you're trying for searching like a specific entity, let me go for a repository. Maybe I'll search for Elasticsearch. Yeah, I'm just choosing the Logstash. If I want to search something called REST, I'm doing in the same repository. You said your search result is being powered. It's true. But there's one more another feature is being powered here is, can you see the highlightation option here?
yes.
This is also powered by the Elasticsearch. This is something called highlight feature. Even this feature is also available in Google. If you search for any document, let's say Logstash and analytics, if you just say here, you might be noticing, can you see the highlighting feature here? It has been dark here. It's not highlighted entirely, but the letters
Okay.
are made highlighted here. So these are the features are generally available in any search engine. So that is what
Okay.
I want to convey here. And why you just also understand why people are suddenly using Elasticsearch for your log processing system. Like any system, the log generation system, it's kind of very weird compared to other systems available in the market. Let me ask you this question: why not choose the MySQL instead of Elasticsearch for pumping the data in the pumping data into Elasticsearch? Can I use the MySQL itself to do the job? So, what do you think the pain point you see the difference?
The main pain point while we are reading the logs and putting into MySQL, it's we have to convert that particular unstructured data into a structured way. So that
Okay,
is really at most of the times because the logs are like writing it its own way, and to make it into a structured way, it's really weird, and it's not worth it to do that particular job. Even I can store everything, but while retrieving back, user has to read that particular log again and again, right? And searching from there again, it will be very difficult.
okay. You're almost there, but I'll say a different note point, but that will contradict your statement. What I'm trying to say is, even if you are using the Elasticsearch, most of the time, not entirely, most of the time, you will also convert the unstructured data to structured data. Like in a proper JSON format, you will be converting it. Then you might
Okay.
question yourself, okay, then what could be the real pressing factor if I have to use Elasticsearch than the database? That's a question we have to answer ourselves. You said right, like a word called unstructured. If my document contains a fully unstructured, what can I do? Like a log file is something very rudimentary which you can handle. But let me give you an example of a Facebook post. Let's say you are in a Facebook or LinkedIn, you create a post. For that given post, you let's say I'm start commenting to the post. What will happen? You're not sure that how many lines I will comment or how many characters I will comment. Do you agree with me? I'm not
Yes.
you are not sure of the length, and you're also not sure of the what is the content I will be typing in the document. My document can be like spawning, like it can contain multiple information. Let's say you posted some photo. I must say that, okay, you remember this story, like last year we went for this place and we had a great time, and this is the incident happened. It was very enjoying and thing, and I'm just ending with the thank for this information. This is the proper unstructured data, the what comment what I mentioned. It contains the place information, their time, and the emotion factor, like lot of the entries here. If I want to do with these kind of system, if I want to do it in MySQL, strictly there is no option for me. The searching capability is like a way harder. If you want to do like a full text search, have you heard of something called full text search in MySQL before?
Full text search is something like a string search kind of thing, right?
Yeah, you might have used something called like operator, right?
Yeah,
You
yeah,
might have used
yeah, yeah.
like operator
Yes,
using a regular expression.
right,
As you might have seen from your experience, people will always not recommend using a like operator because it's something called very time consuming and heavy, right?
right, right.
Yeah. So, but if you go for the systems like Elasticsearch, if the data is more of unstructured, contains like lot of moving part, you are free to use your free text option in Elasticsearch. If you just say that just like a few words, what you remember, you can get the content just like that. Even if you open your Gmail box and start typing for some email thread which you remember the faintly, that's a usual scenario, right? You might remember like few lines from the subject and few lines from the document email. If you want to search, if it's like a traditional search system like a MySQL, you have to specify the content exactly without even a small spelling mistake. Do you agree with me? You will be searching
Yes,
exactly, but what we see in our Gmail or other searching platform is even whatever comes to our mind, like approximately, we give a random item on that and we are able to retrieve the content back. So that is the beauty here. That's something called full text search. You can utilize your full text search or a partial search result from the system. So these are the benefits, what I would say, from migrating from MySQL to Elasticsearch. That's the fundamental difference. Now let's understand what is the key or the pressing factors between the database and the search engine. Okay,
okay,
as you might have worked with database, you might have used all the four operation: create, read, update, and delete. So the MySQL, if you think, do you think MySQL is designed for all? The performance would be very similar for all of it. The create, update, delete. So there is no big problem. But what I'm saying in the case of search engine or Elasticsearch is the main goal of Elasticsearch itself is for the search operation. Then if I said it's only depend on search operation, I will be turning off the other parameters, like something like the reading, update parameter, deleting everything might be slower, but my searching capabilities may be much faster. Because earlier when people designed the database, they thought they have to like persist the content. Now the world has been evolved in a so drastic way, like the advent of big data. They like to crunch and see get the volume of data in such a faster action. So what people do, yeah, they want the search power to be more powerful. So Elasticsearch itself is being designed keeping in mind of the searching capability. That's the difference here. Okay.
okay,
And the second important point, which you might know, like search engine operates on text data heavily. Like I said, the blog post or comment, it can operate so easily. But if you want, if you still want to store the same amount of data in MySQL, you can use something called text field or a long text field, which you can still use it. But the searching capabilities will be much poorer and performance starts to degrade when the document gets very higher. But the traditional database system are ready to work with the table, which is something called rows and columns. It can work so easily. So that's one difference. And the third difference, what you see here is like Elasticsearch are powered using the algorithm, something called TF-IDF or BM25. This is like a very important difference you would see. And the algorithm powering the MySQL is something called B-tree. That's the algorithm is powering the full backend processing of the MySQL engine. And the fourth
okay,
and important property, what you see here is Elasticsearch doesn't have the security and transaction behavior on its own. Everyone, if they have access to the Elasticsearch, they can control the system. But we know that in MySQL we can have like a final role based access, saying that this people can only read, these people can only update. We might do having the complete privilege. By flushing the privilege, we can get the complete control, saying only admin can create and delete. So we'll have a full control, right? So these kind
Right.
of access control can be done in the row locking, table locking can be done in MySQL, but there is no such concept provides in the case of the Elasticsearch. Everything is open. So you people might wonder how they can give a security in production. So generally, people what will do is they keep engine kind of server. They keep in a reverse proxy. So people who are using the Elasticsearch from outside world does not know the IP directly. So they can only interact through the engine server. That's the way they do it, or they keep it behind the firewall. So only the request can come in through the application level. So these are the different ways in which the people offer security to the existing application. So only that particular you are only by logging to the computer they can make some changes, something like this sort. So these kind of ways by which security is being actually offered to Elasticsearch. And the last point what you see here is all the data which is being pumped to Elasticsearch undergoes some kind of pre-processing steps. We will understand in detail what are the different pre-processing steps it takes. But in case of traditional MySQL, there is no any pre-processing. Your data is stored as it is. Even if you go and understand in the binary world, your data is stored as it is. There is no pre-processing step. But there are a few kind of pre-processing steps there in the Elasticsearch. We will see in detail about it. Do you have any
Okay.
questions till now in any of this part?
Nothing.
Great. And if you see the like various terminologies of Elasticsearch, you see something called document, index, primary shard, node, cluster, and field. So document is a JSON document, which you might have seen. Let me just pull up some document for you. It's very small. Yeah. Can, can you see here?
Yes.
So this is like a JSON document. A JSON document is like it contains a key value pair, collection of key value pair in a flattened way or in the nested way. Can you see the nested being done? Now we have
Yes.
something called an object which contains who a and an array. So it can have the nested behavior. So the JSON document is a key value pair which can contain the nested level behavior. It can contain the nested document. So that is a property here, or that's a difference you need to understand. You got it, the clear understanding here, right? What is a JSON document? Someone says
Yes.
a document in Elasticsearch is nothing but the key value pair, okay?
Okay.
And the next part you see is something called index. Index is like a table in relation database. No, this is like kind of wrong. This is like you just have to see it's a database in the whole, not the table. It's a database.
Okay.
Like we create something called create database, right? Similarly,
Mm-hmm.
people create something called index in Elasticsearch, and there's something called primary shard. What's the definition? What I've written here is shard is a single losing instance. It's a low level worker unit. What I mean by low level worker unit is, as we previously discussing about the losing, I said that Elasticsearch is built on top of Apache losing. So each losing instance together form a job and try to form a Elasticsearch node or a instance. So if you see like a shard is like a small low level worker unit of Apache losing. That's what they are trying to convey here. So we also
Okay.
discussing about the use case, right? Let's say in a given classroom, if you have like 100, let's say we have like 100 rows, a hypothetical case, if there is only one table to come and read, so there are 100 requests coming to the machine. So all the 100 requests will be processed sequentially. But as we know that MySQL has a concept of partition, so I can divide my data into multiple pieces. I can say that from 1 to 25 you stay, 1 to 20 you stay in this chunk, 20 to 40 you please stay in this chunk, and so on from 80 to 90. So all the 100 people who are coming for retrieving the content from the system, if they know their ID, let's say 1 to 20 go for chunk 1, and 80 to 100 go for chunk 5. See, I can improve my throughput by dividing into multiple pieces, right? Similarly, that's where the shard also works. Shard will try to take the large amount of data and split into small pieces. These small pieces are called a sachet chart. Okay, hope you got it.
Okay. Yeah.
If you see the example, let me complete the node and cluster, then we will again look back the part. So the node is like any instance of Elasticsearch is something is called as a node. I have to rephrase this statement. So any computer or a desktop or a server class machine where you have installed Elasticsearch becomes the node. As simple as
Okay.
that. The cluster is one or more nodes where you have installed Elasticsearch. Together we combine to process some information. Then it forms a cluster. So that is the difference between the node and cluster. A node is a single entity. Cluster is a group of entity. Together it try to accomplish a job. That's a difference. And the third point, what you see is the field. A document contains a list of key and key value pair. Like we saw, right? Name equal to, if you see something called place equal to India, that is where it is something called key value here. Let me
Okay.
zoom out this part. So can you see this picture here? This is like
Yes.
Elasticsearch cluster. What you see, like multiple machines you have here, and your data is divided into three pieces. That's one. The P1 is called the primary part. P0, P1, and P2, and the replication it contains like R0, R1, and R2. Can you see
Okay.
that all the three pieces of my actual data has been split into different computer? It is not in the same machine. So this is the node 3, node 2, and node 1. Even let's say if I go and destroy the node 3, okay, if I go and destroy node 3, can I able to access all of my data? Is it possible for me? Let's assume that
Yes.
this I completely destroyed this machine. Can I access all my data now?
Yes, you can because you have a copy in other two things.
Yeah, you have the R1 because you have the P1, P2 is there. I have a
Right.
R1 copy, R0 copy here. Still, I can get the complete data. Even if I destroy this machine completely, I have P1, P2, and P0. All my data copies are again available in all the machine. Hope you got right how they design this kind of system.
Yes.
So this is where the sharding algorithm really works. It makes sure that it divides the work in divides its data into multiple computers or multiple nodes, and it helps you to get the data. That's where it works. And the
Okay.
next thing you have to see here is difference between Elasticsearch and relational database. So whatever we call the database, it's called as an index here. So whatever we call as a table, it's defined as a type, and rows as a document, and column as the field. Hope you are easy to transform from this SQL to Elasticsearch, right? If you start
Yes.
remembering this jargon, it will be very easy for you to migrate from what is it SQL to Elasticsearch. Clear?
Yes.
Okay, now I'll share you the installation guide and I'll also will help you with that. Let's look on the architecture. Then let's complete. We'll I help you with the installation also.
Mhm.
Can you see the architecture here? So Elasticsearch is sitting on top of Apache Lucene. Still, Apache Lucene is the fundamental building block. With that building block, you might see something called index and index here. That comes from the Lucene part. And as I said that Lucene doesn't have the clustering ability. Only Elasticsearch has written the clustering ability. So it goes to the cluster and contains the cluster metadata, and all the interface done to the Lucene or the Elasticsearch is done through the call interface or the REST API. So REST API is completely powering the engine. So you might see that this picture might look superficially very simple. It's not like a complete architecture like what we see for other system or a MySQL. If you want to truly understand how the real system would look like, you might have to search with the Lucene architecture. So that might be the right way to understand the system completely. If you search for the Lucene architecture completely, you might see in the picture. Where's the picture? Yeah. This is the right picture explaining the Lucene architecture. Can you see here, right?
Yeah.
Apache Lucene,
Yes.
the core level indexer, text analyzer, text writer, and all the entities what we see as Elasticsearch features, everything resides over here. This is for partially for Solar. So the option what you have to see is the facetting, filtering, the query processing, all the steps is being part of the uh, Apache Lucene. You're clear, right? How it now works?
Yes.
And this is like a simple architecture for the Apache using. You have the corpus, it is being analyzed. Once being analyzed, it's been stored in the index and the searching mechanism. Then it's stored in their own format. This is like the few system design wherein which you see here. This is like a HBase one. We have any questions till now, Makio, on this part?
Nothing. So will you be able to share all these slides with me so that I can
Yeah,
go
I will
through?
be sharing. I just want to collect your email ID. Once you can you
Uh,
share your email ID?
where in the chat?
Yeah, please. That will be great.
Uh,
I don't
okay.
make. I avoid typos there. So every day, as the end of a class, I will be mailing you the materials and the notes what we discuss in the class. Along with
Okay.
I occasionally I will also send you a few questions to work upon. So those
Okay.
questions sometimes will be like open-ended question. Sometimes it might make you to think. It might not be so simple. It might be like few exercise questions also. It will
Okay.
be that small. Yeah. So I will mail you the course content. If you have any
Okay.
question, we will see the installation tomorrow. Before tomorrow's class, can you please do me a favor? Can you
Yeah.
please download? I also send the download link. Can you please download ES 7.2 and Kibana 7.2? Can you download this version and keep in your machine
Sure. Sure. Sure.
so that we don't
So
waste time on that? Mhm.
yeah, I have a server, so I'll download and keep all the things there
Yeah,
rather than
sure,
in.
that will be great. Okay, great, great, Market. Then we will meet tomorrow on the same time. We
Sure.
will tomorrow we will understand the basic installation part. There are like advanced installation and configuration, which is like later part of the course. But tomorrow, what we will see is to get up system up and running, and so that we can start interacting with system. We don't go in detail about the installation part, but we cover partly to get the job done. So in the later part of
Okay.
the close, like, we will be completely spending our energy to understand how to configure and tweak the system and how to scale in a better way. We will be
Okay.
understanding those areas. Okay.
Okay.
Okay, Matthew. Then see you tomorrow.
Sure. Bye.
Bye bye.